You ever stop and think about how a website can handle millions of people trying to buy concert tickets at the exact same moment? Or, how your favorite streaming service doesn't just completely implode during the finale of a huge show. It really feels like magic, but I promise you it's not. It is some seriously clever engineering designed to handle pure chaos. So let's get into how it all works.
Now, really think about that for a second. The amount of data flying around during a massive global event is just staggering. You'd think, right, that our favorite sites would just buckle under all that pressure? So what's the secret weapon? What is it that keeps the whole digital world from falling apart?
Well, the answer is this idea of an invisible traffic cop, a quiet, super efficient director who's constantly working behind the scenes. It manages this endless flow of information, making absolutely sure that no single part of the system gets totally overwhelmed. And this digital traffic cop? It has a name, the load balancer.
And at its core, that's really all the load balancer is. It takes all the incoming requests that are heading to your application, and it just cleverly spreads them out across a whole group of servers. This stops any one server from becoming a bottleneck, which means a fast, reliable experience for everybody. But here's the thing. It turns out there are different kinds of traffic cops for different kinds of traffic.
Okay, so let's meet our first traffic cop. This is probably the most common one you'll hear about, the Application Load Balancer, or ALB for short. And you shouldn't think of it as just a basic patrol officer. Oh no, this is more like a highly intelligent director.
The best way to think about it is like this. Picture yourself walking into a really popular, kind of fancy restaurant. You don't just go and grab any open table, right? Of course not. The maitre d' greets you. They ask what you need, maybe a table for two, a quiet corner, a high chair for a kid, and then they guide you to the perfect spot. That is exactly what an ALB does.
So what makes the LAB so smart? Well, it operates at what geeks like me call Layer 7. Now, in simple terms, that just means the ALB doesn't just see a request coming, it actually looks inside and reads the details. It knows if you're trying to look at images or if you're heading to the checkout page. And based on that really specific info, it sends you to the perfect server that's set up to handle exactly what you need.
So the whole flow is pretty simple, but it's incredibly powerful. Your request hits the ALB, our maitre d' does its little inspection, and boom, you're sent right over to the perfect server, one that's healthy, available, and totally ready for you. This smart approach makes it the go-to choice for most modern web applications out there.
But what happens when the goal isn't really about being smart? What if the only thing that matters is just raw, blistering speed?
In some scenarios, like high-frequency stock trading or competitive online gaming, every single millisecond is everything. That tiny little delay it takes for the maitre d' to read your request, totally unacceptable. You don't need intelligence, you just need instant reflexive routing. And this is where our second hero, the Network Load Balancer, or NLB, steps in.
So this is the key question, right? If they both balance traffic, what in the world makes the NLB so incredibly fast? Well, the answer lies in what it chooses not to look at.
This slide just nails the difference perfectly. The ALB, our smart maitre, is like a mail sorter at the post office. It has to open every single letter to read the contents before it decides where to send it. The NLB, on the other hand, is the postman on the street. It only looks at the address on the envelope. That's layer 4, just the basic network info, nothing more. It doesn't care what's inside the letter, and that's what makes it unbelievably fast.
And this obsession with speed gives the NLB some amazing superpowers. First, the performance is just insane. We are talking millions of requests every second. Second, it gives you a fixed static IP address that never ever changes. And third, and this is super important for some apps, it preserves your original IP address, so the server knows exactly who it's talking to. All this makes it the absolute champion for anything that needs ultra-low latency.
So, we've got the smart director and we've got the high-speed courier. But what about a totally different kind of traffic problem? What if every single piece of data, every single bit, needs to be inspected for threats? This brings us to our third and final challenge, security at a massive scale.
Just imagine for a second that you're in charge of a huge network for a bank or maybe a government agency. You have to scan every single packet of data for viruses, for malware, for any kind of intrusion. How do you possibly insert a security checkpoint for millions of cars without causing the world's biggest traffic jam?
This is the exact problem the Gateway Load Balancer, or GWLB, was built from the ground up to solve. It's actually so revolutionary that it's been called a dream for security professionals. And why is that? Because it does something that used to be incredibly hard: transparent security inspection.
The real magic behind the GWLB is a technology called Geneve. Instead of actually changing the traffic, it just wraps it in a special envelope. This means your security tools, like a firewall, can open the envelope, inspect the original, completely untouched traffic, and then just put it back in the envelope to continue on its way. From your application's point of view, the security check never even happened. It is completely transparent.
All right, now let's talk scale for a second. Imagine you have 20 gigabits of data flowing through your network every single second. A single security appliance, it doesn't matter how powerful it is, would just melt trying to keep up with that. And for years, this was the fundamental problem, the bottleneck for network security when you're dealing with huge amounts of traffic.
And the answer is, it can't. A single firewall just can't do it. And this is the true genius of the GWLB. It doesn't just send traffic to one firewall, no. It distributes the traffic across an entire fleet of firewalls. And just like with web servers, this fleet can automatically scale up when traffic spikes and then scale back down when things get quiet. It actually makes security itself elastic.
So as you can see, the traffic flow just becomes this seamless, transparent security detour. Traffic gets automatically rerouted to the GWLB, it gets spread across that whole security fleet for inspection, and then it's sent right back on its way. It's a really powerful way to centralize and scale up your security without having to re-architect your entire network.
Okay, so we've met the Smart Maitre D, the Express Postman, and the Transparent Security Scanner. Let's pull this all together and figure out when you should use each one.
It really all just comes down to choosing the right tool for the job. The ALB is your smart director for web content. The NLB is your speed demon for high-performance apps, and the GWLB is your specialized guardian for scaling network security. Each one of them is a masterpiece of engineering, but each is designed for a very, very specific job.
So look, here's the most important point to take away from all this. The conversation is never about which load balancer is the best. It's about deeply understanding the problem you're facing. Are you trying to route web traffic intelligently? Do you need blinding, face-melting speed, or do you need to scale your security? The answer to that question tells you which tool you need.
And that leaves us with a really fascinating question to think about, right? As our digital world gets more and more complex, we're talking about AI, the metaverse, things we can't even imagine yet. What new kinds of specialized traffic cops are we going to need to invent just to keep it all running?